So now let's take a look at the term precision. Many people use the word precision and accuracy to mean the same thing, but they're actually very different terms. The common definition, or sort of a simple definition of precision, is the exactness with which you make your measurements. It also could be a measure of the repeatability. That is to say that measurements that are very precise will be repeatable. When you make that measurement over and over, you'll get the same thing over and over and over again. The textbook defines precision as having a small random error. And let me remind you that accuracy was having a small systematic error. So these are the two important errors, the two main errors, random and systematic, and they're both associated with the terms precision and accuracy. If I have a very precise measuring device, then when I make repeated measurements, what I'm going to find is that that variation in my data will be very small. Having a very small variation in my data means that I have a very small random error. If I see that the data is all over the place, then that means that I did not measure very precisely. I either didn't have a precise device or I didn't use it correctly, and therefore I would have a very large random error. I think another good way of thinking about precision, and the way that I would typically define it, is that precision is the smallest measurable unit. If you could imagine having a meter stick that had no markings on it, that device would not be as precise as a meter stick that was broken into 10 parts, that was divided into 10 equal pieces. If it was broken into 100 pieces, that would be even more precise. And you can see the pattern that as the markings get closer and closer together, the precision of that device is increasing. I'm able to measure more places after the decimal place. A meter stick with 1,000 markings would be even more precise. The smallest measurable unit there would be as small as a millimeter. And so how small a measurement that you can actually make is essentially a measure of the precision. Now, clearly the precision will depend very heavily on the device that you're using. As I said, the meter sticks are a good example, but it's not just the meter stick, it also depends on the person. If the person doesn't use it correctly, it doesn't matter that it has a very precise device, they're still going to end up with very imprecise data, but more often than not, it's actually a combination of both. It's both the way that the person uses it and then ultimately the way that the device was created. For example, a tape measure will provide a precise measurement of the width of the classroom. If you're measuring the classroom, a tape measure will do just fine, but if you wanted to measure the width of a human hair, then that's not going to be precise enough. Human hair is much too small to be measured using a meter stick. Now you could estimate it, but that estimate would not be a very accurate estimate. So the way we say that is that the tape measure lacks the precision to make that measurement. And obviously, don't forget that the person that is making the measurement can greatly reduce the precision of the device by just being sloppy in the way that they use it. For example, if you had to use a meter stick to measure something longer than a meter, you'd have to move the meter stick to do so. And as you do that, how you move the meter stick will really affect your precision. If you're very careful about the way that you move it, you keep track of where the meter stick had ended on the previous time, then it would make a big difference in the precision that you would be able to achieve with that meter stick. So, as I saw in the common definition, repeatability is also a measure of your precision. So that's the second way of thinking about precision, is that it leads to a property called either repeatability or reproducibility. And essentially that means to be able to reproduce the same result. If you measure the same object 10 times in a row, you would expect that you would get the exact same measurement. And if you do, you would say that your measurements were very precise. If you got wildly different numbers, then you would think that your precision was probably not that good. So repeatability or reproducibility is simply a measure of your ability to measure and get the same results over and over and over again. If you have a very precise device, you'll get the same thing over and over again. Now clearly, precision is going to play a role in determining the uncertainty. So we saw that precision is a measure of the random error, and so since the random error is very much associated with the uncertainty in a measurement, it makes sense that precision, the precision that you use in making your measurements, is also going to determine the amount of uncertainty. Again, if you think about the meter stick with no markings, and you had to measure something that was smaller than a meter, it would probably not be very precise, and you would have a very high uncertainty. But if you use a meter stick that has 1,000 markings, millimeter markings, then you'll probably be able to make the measurement fairly precisely, and so your uncertainty would be a lot smaller. So for example, if you record numbers in a measurement that the device does not have the precision to measure, then that's going to be a problem. So if I were to measure my height with a meter stick and I found that that height was 1.654283, that would be incorrect because a meter stick does not have the ability to measure accurately beyond this point. So here are decimeters, centimeters, millimeters. Now I might try to estimate this number afterwards. I might try to estimate one more number, but there is certainly no way that a meter stick would have the precision necessary to measure these numbers, to know whether these numbers were actually the numbers that I'm writing. So because the meter stick is only accurate down to 1,000th of or only precise down to 1,000th of a meter, I would only be able to keep those first three digits, the 1.65. The remaining 0.000283, there's no way I could measure that or know whether those are really the numbers. And it's really as a result of the precision that you have for making your measurements. This is the reason why we have this thing called significant figures. And I know there's a lot of teachers teach different rules about significant figures. There's only one correct way to use significant figures. Oftentimes people are a little sloppy in the way that they use them. But the fact that we have significant figures is simply a result of the fact that you cannot measure anything exactly. You can make it more exact or less exact, and that's a measure of your precision, but you cannot measure it completely 100% exact. And so as a result of that, significant figures are a way of you showing what you really know and not saying and not expressing things that you don't actually know. So we'll take a look at significant figures in the next section.